So finally, let's talk about transformations. And the reason is that sometimes our data have certain features that just complicate our interpretation, or they might be hiding something. Things like maybe very asymmetric distributions in a numerical variable. Sometimes they will be in clear violation of modeling assumptions, and this is something we will care about deeply when we talk about regression analysis, such as again symmetric distributions or the fact that the relationships are not linear, maybe. Um, in these cases, it's going to be helpful if we transform the variables such that we pursue a different kind of pattern. So different features that might be more easy to interpret for us or for modeling. And typical transformations are logarithmic, exponential, polynomials. We're going to see examples now. So again, here we have the distribution of prices of the Airbnb listings. And what we say is that, well, yeah, most of the points are very close to zero, but other than that, we don't see much, right? What if we plot instead of the price, the log of the price? Or what if we apply a logarithmic transformation over the price and just look at the histogram of the result? It turns out that it looks something like this. The plot now looks a lot different. And the reason is that here, if you notice in the x-axis, we don't have a linear axis anymore. We have a log axis. So if you notice, the difference between this point and this point is 90 units, but the difference between this one and this one is 990. So that means that the distances get larger and larger and larger as we move towards the right. So what this is telling us is that it's probably a good idea if instead of looking at the price or plotting the relationship between price and something else, we look into the logarithm of the price because the relationship is going to be more clear. So when do you transform and what kind of transformation should you apply? Here you have very basic rules of thumb. And by that I mean sometimes they work, sometimes they don't. Just try and see, but it's not written in stone that this is what you should do. But in general, if you're looking for a distribution that is kind of symmetric and your data looks like that, try a logarithmic transformation and maybe it turns into something like this. And it might be nicer to look into and it might be easier to find relationships with something else. If your data looks something like that, then you could try something like a square root or a cubic root. If it looks something like this, so like a mirror of this one, then you can try a polynomial or maybe an exponential of that variable, and it could turn into something that is more symmetric. Now again, nothing guaranteed here. These are just rules of thumb. Try, apply them, and see if they work, and maybe you're lucky. Now, some other times we're going to be interested in the relationship between two variables, and it's nice if the relationship is linear because the interpretation is going to be a lot better, and the modeling of this data is going to be a lot better. So in this case, we had this relationship between carat and price. It's very much non-linear. So what if we apply a logarithmic transformation on the carat? Again, then it looks something like this. Looks like it's even worse, right? What if we apply the transformation on the price? Then it looks something like the other way around, right? What can we do? Perhaps transform both carat and price? And there we go. So now we have the relationship between the log of the carat and the log of the price, and it looks kind of a linear relationship. That's a lot easier to understand, a lot easier to reason about, a lot easier to model, and a lot easier to plug this relationship into some other plots so that we see further relationships between more than two variables. And the question arises the same. When should we transform and what kind of transformation? Again, rules of thumb here. If your data looks something like this, you could try and apply a logarithmic transformation on the x. If the data look something like this, try the transformation on the y. And if it looks something like that, try the transformation on both. And you might end up with something that looks like this, like a linear relationship. Some other kind of transformations you could try. If you have a relationship that looks like that, try making this polynomial transformation. If it looks kind of the other way around, try the same transformation on the x, not on the y. And if it looks something like that, try transformation on both. And maybe you're lucky and you get a nice linear relationship. So, final words, there's something very important to keep in mind when we are transforming variables. And in this example, we see it very clearly. So what we do here is on the left side, what we're doing is plotting the raw data, transforming the axis. So if you notice here, like we did before, in the x-axis, for example, the distance between these 2 points is 0.7, but the distance between these two is 2 units. So it is the scale, the axis, that is transformed. It's logarithmic. And the same happens here with the price. So what we're doing here is plotting the raw data on a transformed axis. On the right-hand side, what we're doing is transforming the data and then plotting on the raw linear axis. So we transform and just plot it. And what we see here is that now the interpretation of the axis is just the typical one. So the relationship between this one and this one is 0.4, which is the same as to this one, 0.4. So the interpretation of the x-axis is just the normal one, but the values we have in the x-axis, they are not the raw values. So the interpretation of the axis is simpler, but then what those numbers mean in reality for our data, in this case for the carat, they're not, because we are plotting transformed variables, transformed numbers. The interpretation over here is a lot simpler because we actually have the numbers. This is 3 carats, this is 1 carat, this is 3,000 euros, this is 10,000 euros. What changes here in the left is the relative difference or the relative magnitude between consecutive points. The larger the prices and the larger the carats, then the larger the differences we see between consecutive points. But the numbers are what they are. They don't change. They are the raw numbers. So my personal preference is to always do this, because then we can look at the numbers and the numbers have a very clear meaning to us. Those are carats and those are euros. It's just a matter of knowing that the axes are transformed. If we look into this plot, yeah, we get a sense of linearity in this case of the relationship between the two variables, but it's very difficult to make sense of the actual numbers because we have to transform back. So again, up to you, just my personal preference, this one on the left.